Today's quiz. Remember, if you're a distance student, you should be watching this, and you should work this quiz and send me a copy of your work. Okay, work in detail. Also, if you happen to be a distance student, happen to be watching this, as you should be, but I'm not sure most of you all. Okay. You're gonna have to start submitting, and everybody's gonna have to start submitting a copy of their work, although if you're in class, you can just bring it to class. Okay? Your work on the quizzes. On the homework, written out in detail. That includes any graphs. There's a graph on the open math homework. There's a strong tendency of distance students to say, well, I don't have to do anything with that. I'll just answer the question. I want to see the graph and I want to see a reason for deciding whether this thing's a function, whatever it is. I want to see your steps of solving the problems. I don't want to see, here's the problem, here's the answer. I want to see the connection as you figured it out, including any blind alleys you might have gone down and so forth, so I can see what you're doing. Because I want you to pass the course. And people who don't do that generally don't pass the course, although some do. Okay. Don't expect that you're going to be one of the very small minority. Do all this work to prepare yourself for tests. Okay. If you get it some other way, okay, but you're still going to have to do it on the test. No internet, no AI. Only a very basic computer. You can bring your own computer with a textbook in the memory. Okay. So remember, that's what we're doing. Now, I don't have to say that to anybody in class. You all are good. Well, but distance students often try to shortcut things they don't have to do work. Okay. And yeah, this is elementary algebra. It's an intermediate algebra course. We'll be getting into the intermediate algebra next week. You might already know the intermediate algebra so well that you don't have to do all the work. When we get into the intermediate algebra, you're going to need to show it. Okay, and I still want you to do these quizzes. Now, for the distance students, here's the quiz. The distance student, you should be paused doing the quiz. Now I'm going to solve the problems. Okay, we have 4x plus 7 equals 2. Okay, well, I want to subtract 7 from both sides, and there are a couple of ways to do that. I'll add the equation minus 7 equals minus 7, because that's just what everybody wants to do. Remember that equal sign has to be there. If you have a minus 7 here and a minus 7 here, chances are very strong that you're going to get into a bad habit and start subtracting the wrong things. I see a whole lot of it. I want to see the equal sign. And then you're going to subtract that 7 from the 4? No, you're not. Even if this is a 4, you couldn't subtract it from the 4, right? That's kind of a mistake I often see. This is 4x. You can't subtract 4 from 4x. Okay? You don't know what x is. Okay, well, enough of that. We subtract 7 from both sides. That gives us 4x. 4x equals -5. And then we divide both sides by 4. And once they're separate out. Because equations get more complicated, and if you're not reinforcing the steps or writing them out every time, you're not learning stuff as well as you could, and you're probably going to be sorry for that later. Okay, so now we have this 4x divided by 4, the 4 divides 4 of these is x. Here we get -5/4, which we then go back and check. I'm emphasizing this because people just apparently aren't doing it. Okay, I don't know about in this class, but on the whole, you tend to skip that step. We take this back and plug it in. We get 4 times -5/4 plus 7 equals 2. Well, that's the same as 4/12. We can divide the 4 into 4. Okay. Get -5 plus 7 equals 2, and that checks 2 equals 2. And we've got a solution. Okay. Now, you don't have room to write out all the steps in the second problem at this point. I'm going to skip down to the fifth, to the last problem. This problem is very simple. If you remember what to do. I've emphasized this, I always emphasize it, and still I think people just love working with fractions. It's 5 halves x. Okay? Clear the fractions. Always in an equation, if you got denominators, find a common denominator, multiply both sides by the denominator. Common denominator between 2 and 4 is easy to find. 4. And you multiply 4 times 5 halves x plus 2. And you multiply 4 times 13 fourths. Okay, you get 4 times 5x over 2 plus 4 times 2 equals 13. That's an easy step. 4 times 5x over 2, the 2 divides the 4, gives you 2. That gives you 2 times 5x plus 8 equals 13. Now you've got 10x plus 8 equals 13. Okay, now that's a few steps, but they're very, very easy steps. Okay, taking these few steps is way easier than dealing with the fractions. Probably, not probably, but taking a big chance of screwing it up. Okay, you're much less likely to make a mistake if you do this than if you try to work this with fractions, especially if fractions are more complicated than something over 2 and something over 4. Now this equation is really easy to solve. You're going to subtract 8 from both sides. And I'm not even going to write that step. I'm going to say, okay, you get x equals what? 1/2. Subtract 8, you're going to have 5 over here. You're going to divide by 10. 5 over 10 is 1/2. You can check it up here. You get 5 fourths plus 2 equals 13 fourths. 2 is 8 fourths. 5 fourths and 8 fourths is 13 fourths. And if you want to get the solution, write down what I just said and see if it is true. Okay, I said it quickly because I don't want to take last time to do that check. But you need to do the check. It's easy to substitute 1/2 here. Okay. But my thing I emphasize is get rid of those blame denominators. It makes everything much simpler and you're much more likely to get it right. Otherwise, you end up in fraction country. Okay, where you don't want to be unless you have to be. Okay, sometimes you have to be, but not with equations. All right. Now, let's move on to this problem. 3 times 2x plus 5 equals 4 times 5x minus 2 plus 3x. So we multiply everything out. 3 times 2x plus 3 times 5 equals 4 times 5x minus 4 times 2 plus 3x. We do this step. We write out this step, and y'all are doing well with that. I didn't see anybody that didn't write out this step, but I wasn't looking that closely for it. Maybe somebody didn't, okay? You write out the distributive law, so you reinforce the distributive law and get used to it. Okay, then we multiply things out, and you got 6x plus 15 equals 20x minus 8 plus 3x. And we can still simplify this side. We can add the 20x and 3x. Okay. Now, we're going to usually try to get the x's over here. So we got something here that isn't a multiple of x, and we're going to subtract it from both sides. Then we're gonna do that by subtracting the equation. -15 equals -15. Now you notice I started writing -15 here, which would have been correct. But if I'd have written it here, it looks like 15 ought to be subtracted from 23. Although it certainly can't be because 15 is unlike term through 23x. It doesn't have an x in it. This does. This does. So just keep things easy to look at. I write the -15 over here. I don't really care and ultimately where you write it as long as you get it right. Okay? Oh, you're gonna write it over here on this board or something. Okay, but I like to see good alignment because it makes things easier for you to look at. And it makes it less likely that you're gonna make a mistake. And then I get to get better grades. Which makes me happy. And you learn, which is what we really have. So we have here 6x equals 23x. Coincidentally, minus 23, that's okay. Okay, now we still got to get all our x's over here. We got a 23x here, we got a 6x here. Well, we want to get rid of the 23x here, and we want something to show over here. So we're going to do -23x equals -23x. And we add those up and we get -17x equals -23. So -17x over -17 equals -23 over -17. And now we divide -17 into -17, which gives us 1, giving us x. These are two negatives, the result is positive. It's 23 over 17. Again, we'll take this back into the original equation, substitute it, do the arithmetic. Okay, which will give you good practice with fractions. But it works out. Okay, so what I'm saying is, your in-class quizzes look pretty good. Except, remember, I did emphasize this idea. Really want to see you do that. Again, because it makes things so much simpler for you. It greatly increases your chances of getting things right. Okay, now if you're just a student and watching this, the quiz is over. But we put this down, ask everybody, can they find the perimeter? Can they find the area? Okay. And most people got the perimeter. Some people might not have remembered what the word perimeter means. Okay. Perimeter is like how far you'd have to walk, go around this thing. Okay. But, kind of assessing, you have some basic geometric facts at your fingertips. Okay. And okay, how far do you have to go to get around this? Well, you have to walk 7 units here and 12 here. And if it's a parallelogram, these sides are all parallel, which means this side's going to be equal to this one, and this side's going to be equal to this one. And there's a more sophisticated geometric argument that tells us why, that everybody should understand, but nobody does. Okay, so we have a perimeter, and it's going to be perimeter equals what? Well, we could just go around it, 7 plus 12 plus 7 plus 12, which is 38. Okay. A little shorter. Alternatively, the perimeter is 2 times 7 plus 2 times 12, which again comes out 38. Okay. You don't necessarily have to write all of these out, although you can if you want. Okay. But it's 2 times this and 2 times this. Now there's a formula, but there's no reason in the world to memorize a formula for the perimeter. Okay. However, if you did have parallelogram, A units here and B units here, then could you write down the expression for the perimeter? I'm gonna give you 20 seconds to write down the expression for the perimeter. Just see if you got it. So if you got something in mind, write it down. If it's wrong, that's okay. We'll fix it. Okay, now, most people did a good job of writing out the equation for the perimeter. We could write perimeter equals A plus B, then we have another A and another B, so A plus B plus A plus B. Or we could write perimeter is 2A plus 2B, which is the way you usually see it. Some people wrote A times 2 plus B times 2. That's not wrong, but the grammar is kind of a little better if you put the number first. Okay? And then you don't even have to indicate a multiplication. 2A means 2 times A. Okay, now asking the question, what's the area of this rectangle? And why is that the area? So can you write down the area and can you maybe show me why the area is what you said it is? The why is more important than writing down the area because that's pretty simple. Although if you miss it, don't feel bad. We'll fix it in a minute. Now, some people, but not all, were able to tell me what the area is. Okay? But nobody told me why, although somebody wrote down a formula, which is good. The formula is good. Okay, sometimes you have to have a formula because you got no idea why in the world this thing is what it is, right? When you get down to the area of a circle, well, I could show you why the area of the circle is what it is, but I'm probably not going to. Okay? If you want the volume of a sphere, well, there's a great formula for that. But you're a long ways from being able to understand why. Okay? Or the area of the surface of a sphere. Okay? Those are out there in the ozone someplace from where we are in this class right now. Although they're pretty easy if you get into it, pretty solid algebra class, out in geometry class that nobody ever teaches on. Okay. And then when you get into calculus, you learn to do an integral, why that is. That's always a revelation. Not everybody's got calculus in their future, so we don't worry about that. Now, back to reality. Get this 2 by 3 rectangle. What do we mean by the area? Well, when you're in early elementary school, you learn to divide this up. Okay? What does it mean to be 2 by 3? It means we've got 3 units here, so we could do two vertical lines here to split this into 3 parts, right? And then we have one horizontal line, which splits this into 2 parts. That's a 2 by 3 rectangle. Now, in elementary school, especially early elementary school, like first, second, third grade, you just count the blocks. Okay. And then in a geometry class, you're supposed to make sense out of that. Since geometry classes are taught at a pretty low level, that usually doesn't happen. So don't feel badly, but this is why. Okay, if you got whole numbers here, you can divide this thing up and figure out how many 1 unit blocks. I'll say 6 squares. Each has the area of 1 square. But I want to say 1 square unit. Because now the square unit is the unit of area. Okay, so if you want to pave this with 1 foot tiles, well, you'd know how many it's going to take. If you see 1 foot tiles there at the big box supply store, you know how many of them you're gonna have to use to do that 2x3 area that you want to repair. Okay? Now, if you got a 17x48 area, want to figure out how much it's gonna cost to pave that with 1 square unit pavers. Well, you can imagine 17 here and what I say, 43, I don't remember what I said. Same principle applies. The number of squares you have will be this number times this number. Okay? Now, if you try to do a parallelogram, what in the world are you going to do? Well, we'll talk about that in a minute. Okay? Make sense? So there's a formula for the square. Now, Open Math will give you the formula. They might even give you an explanation of why. I think they probably do. Okay? Just something to think. What are we going to do about this? Well, what I'm going to do is I'm going to take this parallelogram. Now, this little square thing here means this is a right angle, 90-degree angle. Okay? So the angle on this side is the same as the angle on this side, it's 90 degrees on both sides, right? And what I'm going to do is I'm going to deconstruct this thing. I'm going to chop off this triangle here. And I'm going to take it over here and flip it around this way and put it here. Okay? So now this one's gone, but it's here. Now, what does that leave me with? What's the shape I get if this thing is now gone? Well, I've still got a right angle here. And I've still got a right angle here, right? Because, well, should be obvious, this triangle has a right angle here and there's a right angle left over here, right? 90 degrees here, gotta have 90 degrees here. So what are the dimensions of this thing now? Well, I took this distance and it's over here now because it's the same triangle, right? So this distance is still 12. Okay. And what's this distance? Well, it said that distance is 6. So the parallelogram has the same area as this rectangle. Twelve times 6, which is 72. And it's the same as our original parallelogram. Make sense? It's a rectangle. It's a rectangle. It's not a rectangle, it's a rectangle. Okay, well, we'll get the spells right. I think I got 2 different spellings of parallelogram there. Yeah, I'll figure out which one's right. Okay. Make sense? So we can deconstruct a parallelogram into a rectangle. Now they're trapezoids. I've got a trapezoid here. Sides. These 2 sides parallel. Okay. This side and this side. I can change that into a rectangle. Not gonna ask you to puzzle it out. What I'm gonna do is I'm gonna go right to the middle of this side and right to the middle of this side. Down here, I'm gonna take this little triangle. Down here, I'm gonna take this little triangle. And I'm just gonna flip it around up here. And now I've got a rectangle. Okay. Turns out that if I know the altitude, I'm not gonna go into the details if I get the formula. It's pretty straightforward to get from here to here. I'm not gonna ask you to know that or test it. If you're curious, you can look it up. And I certainly could encourage curiosity. But let's say that I know that this is 14 and this is 6 and this is, let's say, 8. Or what a scale, but let's just say those are the numbers. Where the 8 is an altitude, it's at a right angle with one of the bases. These two things are just called bases. Okay. Then what I can do is I can average these two bases, multiply by 8. You know, I'm going to change one of my numbers. I'm going to change this 14 to 16 because I don't want to get, because I was going to get, if I average 14 and 6, I get, well, actually, no, that was good enough. Let's keep it at 14. Average 14 and 6, I get 10. Okay. So it means this rectangle I get when I do this reconstruction is going to be 8 here. And it's going to be the average of 14 and 6. Okay. And that's average two numbers. You got to divide by 2. You get the number that's halfway between. Okay. So this trapezoid is the same as this. Now there's a formula. In some ways, it's more instructive to look at it like this, but the formula is important too. I'll let you see the formula. Okay. I recommend, just for the sake of enhancing your thinking, that if you see a trapezoid in your homework, in your notebook, you do this deconstruction. You don't have to explain why it gives you what it gives you, but it's kind of intuitive. You've got a base of 14 here and 6 here. It's like you got that average multiplied by the altitude. Okay, but do your best with that. The deeper you can think it, if you just have to use a formula, okay, just remember the formula. But that's the idea. I think the idea is more important than the formula. But for this course, if you got the formula, it's going to be fine. Okay. You can be able to think better mathematically, though, if you understand this decomposition. It'd be beneficial to future courses. Okay, so I recommend it, but I don't require it. All right. Now, these are important figures, also triangles. And I'm not talking about triangles. I'll let Open Math explain that to you. Well, yeah. If I've got a right triangle, okay, I can take another one identical to this one, flip it upside down, and I can build a rectangle. Okay. Area of the right triangle half the area of the rectangle. We build with two of them. Okay, it's not a very grammatically precise mathematical statement, but the idea should be pretty clear. You take any right triangle, you can take a replica of it, flip it over here and make a rectangle. Okay. I might actually on a test, I might put some optional problems. Like, can you reconstruct a triangle, right triangle into a rectangle? Okay. And if you happen to know, then there's a problem that averages in, and if you don't, I just ignore it. Okay. So it could be beneficial on a test, but it's not required. I would never hold it against you. Okay. I would never allow whatever you do in that, even if it's nothing, to lower your grade. Okay. Actually, there is a way I could get it to lower your grade. A way in which it couldn't lower your grade, which is if you got 0 on everything, you still have 0. Okay, that wouldn't be lower, be the same. It's not going to hurt your grade. Okay, you understand what I'm saying? So it's kind of a good thing to store what might well do something kind of on the test. If you've got a triangle that's not a right triangle, okay, you can take a copy of this thing and put it together with this. Okay. And it would look like this, it'd be kind of upside down and so forth. Okay. Just take this and turn it upside down. And there we go. Okay. Now it's a parallelogram. Okay. Just read something on the internet caught my eye. 2 high school girls figured out a way to prove the Pythagorean theorem using trigonometry. Now, y'all probably haven't had trigonometry. You should have seen the Pythagorean theorem. I'll talk about it a little bit. But no mathematician in the past 2,500 years, even though they've proven the Pythagorean theorem in hundreds of different ways, it was thought to be impossible to prove it using trigonometry because the Pythagorean theorem is the basis for most of trigonometry. Okay? So you can't prove it by trigonometry because you're assuming that it's true. 2 high school girls, minorities, did it. They got curious as freshmen. By the time they were seniors, they proved this thing, which has astounded the entire mathematical community. Okay? You would not expect that of even the most brilliant high school student, because most mathematicians have never done it. Okay? Mature mathematicians. So neither one of them's going to study to be a mathematician. One's going to be a pharmacist. One's going to be a biomedical or bio something engineer. Okay. They're going to be good. I want to hire them right now. I don't even have a business to hire them with. It's really pretty neat. Really pretty neat. And then things like that do happen. But they got absorbed by the problem for about 4 years. It was really, really, really kind of beautiful. I don't know how they did it. They published the thing. It's going to be published in the American Mathematical Monthly, which is pretty prestigious. Okay. I say that as background when we talked a few minutes ago. Pythagorean theorem. So Oh, man, that's such a fast circle. Usually I draw a pretty good circle. Okay, that's gonna, that, yeah, what can I say? Okay. We'll use this one, it's better than that one, it's not as flat on the bottom. Okay. A circle, as you know, has a diameter, which goes from side to side through the center. Every point in the circle is at some distance, it's the same distance from the center. That's called radius. The distance around the circle is about 6 times the radius. Okay? So you can say the circumference, which is like a perimeter, but if it's on a curve, you're going to call it something else, okay? But it's a circumference. About 3 times diameter. So the radius is about 6 times, so the circumference, sorry. Circumference is about 6 times radius. Okay? And that makes a certain amount of sense. Okay, how far do you have to go around the circle? If you go that far around, you're about there, that far again, puts you about there. It looks like about 3. Okay, if you draw a really good circle, you can convince yourself it's probably a little more than 3. Well, it turns out it's about 5 times the diameter, or 2 pi times the radius. So pi is approximately equal to 3.14. Now just pi equals 3.141596 and a bunch of other stuff. Doesn't repeat, it just goes on forever. There's no pattern to it that we can discern. Okay? But it's pretty close to this, and for most purposes, this is fine. If you're doing really precise engineering, you might want 4 units around at 3.1416. There's really no reason to do that, since your calculator will give it to you to n significant figures. And if you want more, you just go to a math engine. You want it to 4,000 significant figures, it'll do that. Okay? But nobody can tell you exactly what pi is. Only approximately. Okay. That makes sense. Now, it's pretty easy to see that the area of a circle is pi times the square of the radius. Now, your book will probably call this pi d, 2 pi r, just d for diameter, r for radius. Those are good formulas. I'm going to write the words out just to remind you what they mean. Okay? But I think you can understand that just fine. Okay? You can distinguish. Okay, well, that does give you 2 formulas. Gives you circle equals 2 pi r. And area equals pi r squared. You notice that both of these formulas have a 2 and an r and a pi, but they're in different places, right? Which makes them confusing. Which one do you use where? You know, when you find the area of a rectangle, you're multiplying a number by another number, a length by a width, right? So you have a length. If you have something that's measured in feet by something that could be measured in feet, right? Maybe it's measured in meters, maybe it's measured in miles, okay? But it's got units of, well, square units, like feet times feet, which is feet squared, okay? Area has to have units of square, okay? Remember what I learned before? When we were doing rectangles, the basic idea of area is here. You can't divide a circle into rectangles, okay? But each of these little area units is one square unit. And we would multiply the width, which is 1 unit, by the length, which is 1 unit, and we get 1 unit squared, square units. Areas have square units. That's something you should internalize to the best of your ability. Okay, so area is pi times the radius squared. And the circumference is 2 pi just times the radius, because that's just the distance. The radius is just the distance. You're just multiplying that distance by a number, it's still a distance. So that's one way not to confuse these formulas, because I'm not going to give you those formulas in a test. There might be formulas I do give. They're just hard to remember. Okay, but that's not one. In the area of a rectangle, it's not. And even a parallelogram. Okay, should know those for sure. Okay, does all that make sense? Okay, I'll just mention that you can get this formula for the area of a circle by dividing the circle up into lots of pie slices. Not this kind of pie, but sectors, okay? When you divide it up into a whole lot, these arcs here might as well almost be straight lines. So you can calculate the areas of the circles that you get. Okay, or the areas of these, the approximate areas of these things. And then you say, well, if I just do infinitely many of these things, they all become triangles. And bingo, we get the result. I could do that, and there's a neat picture that I could draw, but we're not going to do that. Just don't have time. It's not that. I think it's kind of important, but not at the level of this course. Okay. Okay. Well, that's a survey of a lot of what you're going to see with the geometry. So you're just going to use these formulas. If you're inclined, think about what they mean and where they come from as much as you can. You're not going to understand the area of a circle unless you put some serious effort into it. You'd probably be better off putting into something else right now. Unless you're just insatiably curious, which is always better. Okay. Now, other, well, there are 4 assignments to do next week. The second one that I want to talk about today is percents. Now, this is something that isn't part of an algebra course either, but it's something, it's an important concept, and I choose to keep it in this course because in a lot of cases, we want to talk about percents. And we got to assume you know percents, and I find that we can't really assume that because it's another thing that gets glossed over in the curriculum. So what's just gonna write down a few percents, and you write down what you think the results are, okay? Now, don't write all of these things down and then start answering. Write this one down and answer it, then write the second one down and answer it, okay? And so see how far you can get. And incidentally, percent is not a button on your calculator, it's a calculation, okay? So you should be able to, if you understand percents, that one and that one ought to be obvious, and then this one ought to be fairly easy. And if you gotta do a little calculation, do it off to the side. Okay, let's just think of these numbers. They get harder. First couple should be easy, but let's make sure. And then we'll see where we go from there. Okay, now, there's an intuitive idea. What's 50% of something? 50% is half, right? So the easy way to get this is just know 50% is half. Okay, but let's explain that a little bit though. Percent means per 100. Okay, now if you compare 50 with 100, how much of 100 is 50? Is it more than 100? It's less than 100. It's half of 100, right? So 50 is half of 100. Percent is one half. Fifty percent of 20 is half of 20, which is 10. Okay, there's a basic understanding what percent means. So 50% of 20 is 10. Now, there's a way of calculating. If I wanted 57% of 20, you might have to do a calculation. It wouldn't be as obvious from the reasoning, okay? wanted to give you one that was obvious to start with, but it's not obvious to everybody. So first place, you should understand that percent means per 100. 50 per 100 is 1/2. Okay. If you've got $100 and I give you 50 for every 100, you're getting $50, right? You're getting half. If you get to keep your 100, that's pretty good. But if you got to give me the 100 to get to 50, that's not good, right? Okay. Well, okay. So 50% means 0.50. Fifty percent of 20 means 0.50 times 20, which we calculate to get 10. Now I just realized we're out of time. It's been taking time to do these things. 10% of something is 1/10. A tenth of 90 is 9. Okay. Now you're going to need to work the assignment on percents. We're going to talk about it a little more next time. Let me just take a quick look and make sure what I'm telling you is true. Yeah, the stuff in percents won't be due until the weekend, until Thursday, okay? But I strongly recommend that you spend some time looking at the videos and working as much as you can with that assignment before the next class. Because then we've got to do, we've got to talk about formulas and inequalities. Okay? Inequalities are just like equations, except there's one additional rule, so that won't be hard. Okay? As long as you get that one additional rule. Formulas is going to strain you a little bit. So we're going to have to spend a good bit of time next time talking about formulas, but we'll also talk about percents, and we'll also talk about inequalities, okay? Be prepared to talk about percents because it's something that everybody, we have to assume you know basic arithmetic, okay? And if you don't, well, people seem to be working hard. Some people are working really hard. So do what you can in percents. Get as much of it into your head as you can so you can understand the rest when I clarify it next time. Because some of this can be a little bit tricky. It involves a little algebra sometimes, okay? So come in as prepared as you can be in 2 days to talk about percents. Now, balance that with the other things you have to do between now and then and do what's most reasonable, okay? Okay. Let me just close Zoom out here so you can not worry about walking in front of the camera.